Welcome back, guys. So, what did we do today? Yeah, yesterday we managed to get through one issue. That was that um, there were I didn't have proper access permission for my page table entries, so those entries were only writable in EL1, and when I tried to access them through EL0, I got some permission files, and I was wondering, should I update it in directly in the page block descriptor or from within the there's some bit that needs to be set within TCR, the control register, something like that, and figured out that it has to be within page block descriptor, and we found out the actual bits and the actual rewrite permission that needs to be set, and we added that, and boom, we did get it working. Right now, let's me just run it. If we run it, let's just break at user process. Let me just okay, if we break at that, as you can see, it's within user process. Let's break that and run it, and we are within the user process. I believe already it did work, because we were able to reduce the maybe this instruction will just work fine, because we are not actually using the SP. So yeah, let's try stepping into it, and as you can see, it is still working. So and what is our current SP? And it is, as we know, it's pointing to 7000 minus, because we added 1 KB block after C6000, that is 0xC123. This was our address plus 4096. This is what we have allocated, and we took the final address as the starting address of our stack, and it just worked fine. And now when we run it, what's the issue? Looks like we are still stuck, but I know why we are stuck, at least in this case. We still get an error, and the error says this instruction, and the ELR is this. Let's just check this then. Probably it's because I don't have any mapping for the UART, because UART also needs so if I'm using UART from user space, I still need the actual mapping. I guess instead of giving that, it's better to just write the syscall. So we just call the syscall from the user space, and the syscall internally within kernel space uses printf, something like that. It would be far better, I think. First, let's just check what this address is. So it is somewhere inside str length. So let's just confirm one thing. If our scheduling is working, let's just switch between both processes without doing anything. It's just simple while loop. What happens then? we still get an error, or we still get stuck. Okay, let's check. But currently the ELR is this. What is that? Okay. Oh, IRQ. I mean, something happened. That's why it got into IRQ. Maybe there was a different here. Probably because there was timer interrupt. See, it's an IIQ, and we stopped here, so it's not an error. Probably we are just not handling. Yeah, we were just executing something here, and we got an IIQ. And our ELR is set to the origin address. That's fine. And we are switching from EL0 to EL1. That's fine. Now the thing is, as soon as we come into EL1, now we need the table entry back. So we need to switch back the TLB1, because as we know, we seem to be using TLB1 to this. We are also using this register from within our kernel because of probably the ranges. I am assuming that. Let's see. In that case, ELR IRQ entry. Okay, where's my vector stat? Vectors. Got an error at this, so we need that table entries even before we switch. That's just sad. I think we could just add that table entry there. It's not that hard. We can add, we can just fill in our user space with that with this particular tables. We need I mean, it's not that, it shouldn't be that bad. Okay, let's just try that. Let's just add that. Let's just add that here. What are we supposed to add? The issue here is let's just write it down so that we have some future as reference, or at least I'm assuming this is what is happening. So right now the user level table is working, but the moment we get an timer interrupt, we have to switch back to the EL1. That means, but we no, in EL1 we are using TRB 01 to 01 register, 0 register, but in this moment, at this point of execution, this TBR0 is pointing to user space. Table, so it won't have the entries for the executing anything in our vector table. I think this is what is happening. So maybe just to check, we can just add the entries into our EL1 now, into our user level table, and see if it's working, and then we can think about a proper solution for this, or maybe move the entire kernel out of this range. I don't know, something like that. And I'm wondering if I'm switching back from EL1 0 to EL1, shouldn't I get into what is that? Shouldn't I be getting into a kernel FFFF address? Why am I getting into this address? That's still a mystery. Let's just add that. Well, even if we care, why is that? We enter into the EL1, we are not inside 0xFFF, because when we actually went from EL1 to EL0, we were inside 0xFFF, and when we came back, actually when we came back, we are actually inside an interrupt handler. Okay, but still, what exactly is an interrupt handler? It's just interrupt handler is just going to find the index within the vector table and run it. That is what an interrupt handler is. Based on the interrupt, it is just going to just call the index, because as you know, if it's a normal IRQ, it is just going to know that it can call this index. So it's technically not doing anything special. So probably because these numbers, these addresses are hard coded. It will get into this address, but still we are in EL1, so we are actually using page table entries to map this into the actual physical address. That would be identity mapping. Okay, that's fine. That's fine. Still, 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 my question would be that uh, is there any way to switch tables the moment we get into a mm, interrupt handler? Because we are inside uh, we are currently inside a user process in EL0. There is an interrupt, and currently the TRB0 register is set to user processes table, and the moment the interrupt comes, we get into an interrupt handler, and the first instruction within the interrupt handler needs the table entries of a kernel. Yeah, now I get the issue because I am using TRB0 register from within kernel. That's why the whole point of having two different registers is that you don't have to switch between them. Whenever you are inside kernel, you can just use the TRB1 register, and whenever you are in user space, you can use the TRB0 register. So you don't have to switch. It's just that based on the EL level, the respective TRB register will be used. But right now in my design, for some reason my kernel is also using the TRB0 register, so I need to update the TRB0 register when I'm inside an interrupt handler, so that's not actually possible. So only valid thing we could do right now is just that update the user table with those entries, so there will be entries for that instructions. At least let's just try that. So we have the map user to physical. Let's just call this for 8000 to add kernel entries from 80x800 1 to 3 1 2 3 4 2 0x let's say 100 into, let's say, 40 entries. So that we are going to map 40 pages. So for I time 0 I less than 40 I plus I, and we just add map user to physical. Let's just put uint 64 current. That would be 0x800 1234 plus 0x1000 into I. That should be fine. And we pass the ID and CU. That's it. Now we should be able to map everything. For every 4 KB page we just map. I think it should be fine. Let's try it. And this is inside 2000, so definitely 2000 will be mapped in the third entry. So let's try. Okay, we still haven't. Yeah, let's just try what it is. It's yuff. Now it's there. Now the error is yuff. It's not table entry error. What was the previous error? Okay, previous error was just 7. Probably that's level 1 error. Right now we have yuff. I guess yesterday when I was debugging, yuff means permission error. But aren't we adding permission for every EL? Yes, we are adding permission for all EL. Okay, let's just check it. So right now we have an entry for this, but we got some error. I think this is permission fault. If it's a permission fault, how the fuck do I fix it? I'll have to add the extra bits to it. But I have already added it. Okay, let's just double check what is that error. Then we can again do probably something like this. You just need to know what this code is. Is it some access fault? Okay, that means yeah, it's permission fault in level 3. So translation did succeed. Now the issue is the permission is denied. I guess we need to set this bit. Let's just check what is this bit is. PNX bit. Code from specific region when a processor is running in privilege levels. Okay. Well, it makes sense, but my question would be, how do I fucking remove that? I think this is the one that we checked last time. Because here if we come down a little bit, no, I guess in this we should see, okay, it's in the bit 53 and pnx what privilege execute never. So we have to set both the bits as 0. I don't know. If we set it to 1, then it would mean that privileged execution is never, so we should never execute anything in that. So I guess we just have to set both the things to 0. We can try that. But privileged execute never also, this okay, I think it should be just fine. It's pxn, right? Let's try it then. Xn bit, and it would be switch 1 to 53rd bit, no, 52nd and 53rd. I don't know, probably it's already 0 there because we don't set anything, so it must be 0 there. To 52nd pnx unx uxn pxn uxn. Let's just add pxn and uxn. Let's see what is going to happen. Just fucking update this. Maybe we need to update truth bits and 54 too. I don't know. What do I put 54 here? I need to set the 52nd bit and 53rd bit to zeros, which probably is already 0, so I don't think we're gonna see anything different, but let's just try. Yeah, we still get the exception. We can also add 54 just to be sure. Okay, let's try. We have faults. Okay, it's still the same fucking error, so probably we have to move the entire fucking thing out of this range. first of all, why the fuck am I using ELTRB0 from EL1? This question just eludes me. But definitely one thing is clear, because if I don't add it, I get different faults. I get here, come here, play this. I get 0x7. That means it's what's that? We just don't have the page table entries. You can just check that. That means translation fault at level 3. So we don't have the entries there. But in our case, after we add this, maybe we can even add it for like 100 entries. After we add the page table entries, we get an execution fault. See, permission faults. How the fuck am I gonna get through this permission fault now? I guess I've already added the permissions. What sort of permissions do I actually need? Let's double check that. Okay. At least it says we have to set this BFP1 to 0. But we fucking tried that already, and it did not give anything. Maybe the bit was wrong, I don't know. We are shifting zeros to that bit. Yeah, execution allowed, so I need the 0th bit, right? If I set it to 1, then that means EL cannot execute. If I set it to 0, that means EL is allowed to execute. Oh, okay. I can just do what the fuck is the difference even if I put this and make it zero that bit this way or my way, what would be the difference? Oh, okay. If okay, this is R. That means if the upper if the actual value already had the bit set to one, that means the value would just still be one. Okay, fuck me. Then I could just do this, right? How do I set 0 in 53rd bit and 54th bit? Hmm. I just and that. That's it. That was my issue. I don't have to do anything that it has to say. It is just probably saying something unnecessary. I can just and it with and it with this p and x. And I guess maybe the bit is 53rd and 54th. So it's 53rd and 54th. And because I have directly set it to just, I think I don't even have to set anything because 0 is just 0. But just to be sure, we just simply put shift is not gonna do anything, but we put it, keep it to show the bit num index. Okay, and we just and that bit. We and that bit. And you can also and the if we and it, both the values should be 1, only then it would final bit will be 1. Now the both the values should be, at least this value should be 0, so the final value will be 0. Last time the issue because the problem was that I was R-ing it by adding an R here, and that was just so fucking stupid of me. Okay, let's try now. Okay, now we fucked up big time because now we have an error here and it says a page false. Why? But I meant it's always executes. If it's always executes for both the things, how come this will be an issue. Okay. I'm adding the entire thing. So that makes sense. In that case, then I have to keep one here. Only then, only that particular bit will be 1. Particular bit will be 0 and rest of them will be. So the issue was that if I put 0 and I AND everything, every other bit will be masked. That was again so fucking stupid of me. So if I put 1 here and then I unmask it, in that case now I would get only the 53rd bit as 0 and everything else as 1. And if I AND it, the other bits will stay the same. I guess that was the whole point of ANDing. Okay, at least we still have the same error, but what? Why do we still have the same error? We just added it. We added the 53rd bit and 54th bit to be zeros. Maybe we can also add the 52nd bit to be 0. I need, this is 1 bit and this is 1 bit. So if it's 53rd and 54th bit, or 52nd and 53rd bit. I think it's 53rd and 54th bit. Let's just descriptor page. They both have the same indexes, that's why I reused it. Okay, now let's see what the fuck we did wrong. Or at least let's check with the general consensus. Dude, that part is fucking fine. It is working since forever. Okay, so this is just fine. It's just saying for security reasons. And we don't have to do this. And this exactly does the same thing. I think so. My question still remains the same. What the fuck is wrong? I have set both the bits to 0, so no matter where I access it, it should just say you can execute it. Maybe I can put 52 on 53. That's the only thing I can check. We still get the same fucking error. Now do it 54. Now we have masked every bit in that range. If we still get the same error, maybe I just have to check what we get in the end. Let's just put a print statement here. What is that? Printer L3 and percentage L. Yes. What is the final output? Because we are going to be dumped with lots of logs. That's fine. We can manage it. Okay, this is what we get. But that's for that. I guess we need the inside k-main. We need to see it here. After this, we can check one there and we'll get an idea of where is after this. Okay, we have it here. Let's just copy this and we can go here, paste it here. No. Yes, decimal to hex. And that is my L3. This is my L3 entry and it's 0x. Eight 0001443 and everything in the front is zeros, I guess, because that's why we don't get anything. We just have the end values, because even if we don't put anything, I think those values will be zeros. Let's double check that. Yes, that's why I thought, because even if we don't put anything, the upper values are still zeros. So the permission should have been working. L3 page block entry decode. So we have access bit set, and it's a valid L3 entry because it's 1 and we have access bit set, and we have data permissions. What data permissions is? Read. Maybe it's fucking with me. Okay, maybe I just have to change this. How is 53rd bit set? There's nothing in the top. How the fuck? This is just fucking with me. Let me just check it in Python. Oh fuck me. There's no fucking and. See, we get 0. We fucking get 0. Fucking LLM is so fucking stupid. Oh fuck me. I have no clue. I know that you are fucking wrong. Okay, so there's something like this. So any writable page is, maybe this is just fucking hallucinating, but at least we can try it. Any writable page is treated as execute never. Okay, we have to do this in MMU. I think I don't even use this register. I don't know if this register is even valid. What is this register? I think maybe I am using this register. Okay, this probably is inside. Yeah, it's here. So we will probably need to, but it didn't say anything like this here. Whatever this was that. This 19th bit WXM. Um, is there something like that? Okay, so there is something like that. Okay, so it does exist. And what's the bit? What's the index? Bit index. Is there any way to find that? I think it would just say that it's 19th index. Every time I just paste it, it's just throwing in some new random word that I don't know. Instruction fetch is patta. The fuck? No, I'm not doing that. Am I? Why did I block this memory as... No, I never mapped this as device memory. You fucking moron. I don't set that to device. What? What the fuck? Fix the page descriptor. What is attribute index 1? Maybe this one? Okay. What are we supposed to... What does that even mean? Okay, so this is the one that sets if the particular region is whether it's a device memory or normal memory. Okay, but what exactly am I setting currently? I'm not setting that bit, so probably it must be just set to normal. My my case, I don't even set that bit. Because yeah, I don't set that bit. Do I set it? No, I don't think I set that bit. Because I set is valid, is page, and access bit. That's it. Also access permission bit that was added recently. Nothing much. So is my whole why the fuck is my MIR 08 device? I don't fucking understand anything. Let's just think about it again. It allows the system to specify the memory attributes like device memory or memory to a memory page based on the index value. Okay, so it descriptors index must be set to okay. So we have 8 possible values, and every bit, every page can every page can set this 8-bit index. This index value will be so every index will be registered in this register. MEIR register. So by default we have 0, so we are saying we are asking it to use the 0th bit, 0th index. So if we are asking it to use the 0th index, what is stored in the 0th index? Zeroth index just has zero. What the fuck? What are those predefined values? If we set it to index 0, that means it's normal memory, you fucking moron. So it's just fine. So what am I setting? 8. Wait, let's just check this. Oh, fucking hell. What will we get? Should I put hex? We're just moving that to 8 bit. And we get this final output. 0, 0. This is the most stupidest hex value I have calculated. We're just moving this to 8th bit, so it moves here. That's fine. What else? So if that's the case, that just means that I'm picking the 0th index there, and the MIR, what exactly am I putting there? Predefined values of MIR 8-bit encoding stored. Okay, let's just say Okay, so attribute 1 means normal memory in my case. Okay, fuck me. It's device. Okay. Okay, so if I write 0 0, that means it's that means if I don't write into MIR register, by default the index 2 will be 0 0 and index 0 will be FF. But if because I have written into my MIR that is 0th index is 0 0 and my second index is FF, that means if I just select the 0th index, that would just give it as a device memory. Okay, so I have to set the bit to 2. Okay, maybe that's why I have set it to attribute index 0 is device, and then attribute index 1 is normal memory. Okay, let's just also copy these things because for future reference. And whatever I write into table descriptor. What about page descriptor? What about page descriptor? Does it to set this value? Okay. Okay. Let's just put this. Page or table. I don't even know if this is. Must set the index bit to specify the memory attribute, and we can have multiple memory attributes. I guess by default this is the R, maybe it just hallucinated or whatever, but in our case the 0th bit will be just 0 0, which is device memory, and if in the first bit is set, that is FF, which would be normal memory. So I guess I have to set it to 1. That's it. I have to set the bits 2 to 3 to value 1. Okay. So I can move to true. Should this be enough? And all those bits are already set, so we don't need that. Let's just try it. Nope, didn't work. Still have the same fucking error. Maybe we have to add it in every entry. Oh, but it is saying it's a fault in level 3. Let's see if this descriptor is fine. Well, I believe my MIR is configured. Or I can fucking remove that and let it be 0. That's also an option. Let's just fucking remove it. And remove this. Do I have to write it, or does it have a default value? That is what we have to confirm. And let's just get into here and remove this too. Let's see if the rest of the code first of all works. Looks like the rest is working. And we have the same exact faults. I don't know. At this point I'm clueless. Fucking clueless. Maybe this is not the issue. Because even without that I'm getting the same fucking error, because maybe there is different attributes and we are selecting the 0th attribute, and probably the 0th attribute is something. What is this? Okay, let's just bring it back to the basics. Okay. We don't need this. Let's check it one more time. Or maybe we can try to infer something. What do we get here? We get an access false. We get a permission execution false because we are adding a page table entry and through which it goes there, and based on the page table entry we are not supposed to execute it. Okay, that makes sense. And initially we thought about we have a page table entry, but it does not have proper execution permission in EL1. So how do we give that? We need to probably, but first of all I am using the same way of adding table entries even for my kernel, even for my EL1, because even in EL1 there are page table entries that is mapping this particular location into the physical, because even my kernel is just a virtual space, and in that virtual space, let's say kernels virtual space 0x80000 is mapped to physical 0x80000, and I added this map manually. Where am I adding that? It's here. Is here. Yes, it is here. And this is 8000. I'm mapping that to another 8000. But that's a L2 entry. So let's see. Let's check this make block descriptor. And it looks like this. It looks like this. It has a physical base and it has, and I'm doing something which I don't, I guess I'm moving this to the 12th bit and then I'm shifting it. No, I'm bringing this from 47th bit to, I'm bringing this 12 bits down and then moving it back to 12th bit, so that the final 12 bits will be set to 0. I guess that's the one. That's fine. But I don't set anything else other than that. But this entire thing is just set to 0. Maybe that's why it fucking works. In my case, in L3 descriptor, that's not the case, because here here we don't do that. Here we have final bit set for some reason. Here the final bits probably may be used and we have some random values there which could fuck up things. And maybe that's exactly why we get a permission fault in L3. And remove this. Wait. What were the final bits actually? Actually, 0th bit is set, first bit is set, and lots of stuff is set here. Second bit is not set, third bit is not set, fourth bit is also not set. But we have first and second bit set, which is fine because it's a block descriptor. Okay, what about the fifth and sixth? Oh, shit. In range 1, 0 to 63. And okay, maybe I was using Rust syntax. What about this? We also need one more information. Bit I equal to this. Okay. We have set 6th bit, 10th bit, 11th bit, 12th bit, and bits like that, and also 16th bit. Okay, let's print make block descriptor and see what other stuff are printed here. Let's see. Okay, we fucked up something big. What did we change? I think we didn't change anything. Did we change anything? What the fuck did we change? Change shit. Come on. We get some faults. Okay, I guess it's time to just put control is it. this line. Didn't do anything much. Just because we removed that line, we fucked up. But that is not even used inside here. What the fuck? Okay, whatever. Whatever. Let's just make block descriptor and disk. Let's just print this. Okay. This is fucked again. The moment we do this, we are getting fucked. What else did we change? Oh, maybe. Understood. Because this is make block descriptor and it is called within MMU unit and I can't call printf there. Okay. Got it. So the issue was my printf, not anything else. Oh shit. So I don't have a print. I can't print that. So I have to rely on what can we rely on here? So technically we have an issue that whenever we jump from EL0 into EL1 during a timer interrupt, we are trying to execute the next instruction and we get an execution false, not the page false. And based on our current research, I guess we just have to write it. If not, we won't remember any damn thing. Final thoughts. We are jumping, executing in EL0. We get a timer interrupt. We switch to EL1. The first instruction here, which is just vector for EL1 IRQ entry is getting false and the fault is 0F. That is permission fault at L3. So far we tried to update the PXN and UXN for the L3 entries, which is always 0, so nothing changed here. And then we try to index the proper attribute from MIR register in the page entry which is currently set to 0, so we are indexing 0th, which is pointing to device memory. Not sure if this has anything to do with our error, but it is possible that we are fogging something here. Ducking. So in general, we just have to figure out how to give execution as such, but in general, we have to figure out how to give execution permission for this table entries, page entries. I guess that's what we have to do for next week. Okay guys, I guess this is what I have gotten so far. We'll think about it next week, I suppose. Okay, have a good day.